Welcome to the Explainer. Okay, picture this. It's 2026. You're a support engineer. The ticket queue is piling up. Your Slack alerts are literally flashing red. And you have exactly 5 minutes to figure out why a customer's transaction just failed. You know the drill, right? In this kind of high-pressure environment, guessing simply isn't an option. And clicking aimlessly through graphical admin panels, yeah, that just takes way too long. That's exactly why rapid, precise SQL skills act as your absolute ultimate superpower for root cause analysis.
So, let me ask you, how fast can you actually triage a genuinely vague support ticket? We've all been there. You get a ping from customer success that basically just says, hey, it's broken. Relying on manual data sifting? That basically turns you into a very frustrated search party. But when you wield a well-crafted SQL query, it instantly transforms you into a data detective. You bypass all the noise and pinpoint the exact row holding your answer. To really wrap our heads around what we're hunting for today, our sources highlight a really interesting core philosophy about advanced database architecture. They point out that support tickets in 2026 frequently involve the reconstruction of business events across three primary tables. Those are users, orders, and transactions. You see, a single user action just isn't one row in one place anymore. It's like a giant puzzle. Modern triage means you have to gracefully navigate these complex, multi-table business events to find that single, pesky point of failure.
So here's our roadmap for today's explainer. 1. The support engineer advantage. 2. The ticket and database connection. 3. Filtering the noise. 4. Joining the payment data. And 5. Case closed, finding errors.
Let's dive right into part 1, the support engineer advantage.
Now, I know what you might be thinking. Doesn't AI just do all this for us now? Well, our sources make a really fantastic point about this. AI is a productivity multiplier, definitely not a replacement. Sure, tools like AI to SQL are going to handle, 80 to 90% of your everyday routine queries perfectly fine. But when it comes to complex performance tuning or weird edge case debugging in production databases, that absolutely still requires your human expertise. And AI might draft the baseline, but true mastery of SQL optimization, actually reading the execution plans and knowing the architecture inside and out, that's what separates OK engineers from truly great ones.
Moving along to part 2, the ticket and database connection.
All right, let's look at our before state. This is a real-world scenario, a raw support ticket right out of the queue. Customer ID 10482 says their payment failed on Tuesday. Take a second to think about that. There are no error codes, no specific order IDs, literally just a vague time frame and one very frustrated customer. This is our objective today. We need to find out exactly what went wrong for this specific user on this specific day.
First things first, we've got to connect to the data. For our demo, we're using a local MySQL sandbox loaded up with a sample e-commerce schema. So you launch MySQL Workbench and open up your target connection. Now here's a really great proficiency hack straight from the documentation. You just right-click your target schema and hit Set as Default Schema. Behind the scenes, this runs a Use Schema Name command. By doing this right out of the gate, you don't have to constantly type out those annoying schema qualifiers in every single query. You're instantly set up to write clean, fast code.
Which brings us to part 3, filtering the noise.
Okay, let's start building this query, starting with a super foundational where clause. Select star from orders where user ID equals 10482. By doing this, we immediately filter out the millions of other rows in the database and isolate just our one specific customer. It's the absolutely crucial first step in cutting through the noise.
But wait, how do we handle the time frame? The customer said it happened on Tuesday. So we slap on an AND clause utilizing the between operator. We translate Tuesday into hard dates, strictly bounding our search between May 5th and May 6th. Using explicit boundaries like between is a huge deal because it allows MySQL to efficiently filter rows without having to painfully scan the entire table.
All right, part 4, joining the payment data.
Here is the catch, though. Our orders table only tells us that an order was attempted. The actual payment status and that critical error code we need, they live in a completely different place, the transactions table. But if you look closely, both tables share a common key, which is the order ID. That means we can mathematically link our isolated order record directly to its payment counterpart.
To pull this off, we use an inner join. Simply put, an inner join is a SQL clause that returns only the rows with matching values from both tables. We don't want all the orders, and we definitely don't want all the transactions. We only want that exact intersection where the order ID in our filtered orders table perfectly matches the order ID in the transactions table.
And boom, here is our completed investigative query. We're selecting the order ID,
the payment status, and the error code. Notice how we use table aliases, O for orders and T for transactions, just to keep the syntax nice and clean. We gracefully link the tables with an inner join on the order ID, and then apply those original filters for the user and the date. In just a couple lines of code, we've built a highly specific, highly performant tool.
Let's wrap this up with part 5. Case closed, finding errors.
So you hit execute, and in literal milliseconds, the noise clears and you get a single targeted row returned. Order ID 88492. The payment status clearly shows failed. And best of all, we have a specific database error code staring right back at us.
There it is, our smoking gun, error code 1179. If we quickly consult our MySQL documentation sources, it instantly confirms that error 1179 means transaction is read-only. Actually, think about what that means. The customer didn't have insufficient funds, their card wasn't declined by the bank, the database itself was stuck in a read-only state at the exact moment they tried to check out. You just went from a totally vague complaint to a precise, actionable infrastructure issue in minutes. Just look at this night and day difference. Before, we were dealing with the anxiety of an ambiguous ticket. That leads to guesswork, bouncing the user between departments, and wasting everyone's time. But after applying just a few minutes of targeted SQL, we have absolute, pasteable certainty. We can prove order 88492 failed due to a read-only error 1179. Now, you can confidently reply to the customer and escalate this to the infrastructure team with hard mathematical proof.
As a modern support engineer, your database truly is your absolute best diagnostic tool. It's a real game changer. So the final thought I'll leave you with today is this. When the next incredibly vague ticket inevitably hits your queue, are you going to guess or are you going to write the query and investigate? Master your SQL, use your tools efficiently, and become the data detective your team needs. Thanks so much for joining me for this explainer.